Sorry about that. Filming on my phone and a phone call come in. Okay, so we're changing the y to f at x now. So we have f at x equals x squared minus 3. So f at x equals x squared minus 3. So now what we're doing, instead of f at x, they're saying it's f at 2. So we're going to substitute the 2 into the x here. So we have f at 2. So what that means is they want to know, what does this equal when we substitute 2 into our x? So we're going to substitute, so since we put 2 into this x, we have to put 2 into this x as well. So it becomes 2 squared minus 3. So we have 4, 2 squared is 4, minus 3 gives you the answer of 1. Okay, so what that means is when x is 2, y is equal to 1. So if you had to find a point on the graph, it would be 2 and 1. Okay, so again, so it's supposed to be f at x, but now it's no longer at x, it's a 2. So that means they put a 2 into the x, so we substitute the x and the 2 into both of these x's. Okay, so they're saying, what is the function when x is 2? So we plug it in, and we get the answer of 1. So if we were asking for a point on the graph, this would be 2 and 1. Actually, maybe I should do that. I'm going to rewind a little bit, because that would be better for this example. This one I should just use the graph, because we have a graph here. Okay, so what I'm going to do here, it's going to change it up. So I'm going to graph this. So x squared minus 3. So in grade 10, you learned about quadratics. This is a quadratic because it has this square here. Okay, so we have y equals x squared minus 3. So in the very parent function, I'm just going to draw it lightly. A quadratic goes 0, 0, 1, 1, 2, 4, 3, 9, or negative 1, 1, negative 2, 4, and negative 3, 9. Okay, so it would look something like this. Okay, so but that would be if it was just x squared. And when I mean the parent function, I mean it's just x squared. But now we're doing subtract 3. So if you guys can remember from grade 10, that minus 3 or subtract 3 means to move the graph down 3 spots. So we're going to move this whole graph down 3 spots. So instead of starting at 0 and 0, it now starts at 0 and negative 3. Sorry, this is a bad eraser. It's not going to really work very well. Oh, we'll just work around it. Okay, so we're going to learn all these transformations again. What is the a value? Last year you learned it was h and k. So we're going to change that. This year it's going to be c and d. So we're going to learn all about those transformations later in the chapter. So right now I'm just going to show you a quick way to graph a quadratic that has an a value of 1. And here's the little trick. So you find your starting point, and then you go over 1, up 1. Then you're going to go over 1, up 3. 1, 2, 3. Then over at 1 and up 5. Okay, and then we do the same on the other side. 1 left, 1 up. 1 left, 3 up. 1 left, 5 up. And that's how you get a quick way to get your quadratic or the graph. Okay, so going back to this question, so it says, what is f at 2? So f at 2 means, what is the y value when x is 2? So if we went to x is 2 and we go up, our y value is 1. So that's what we just found out here. Okay, so we have the value of 1. Okay, next question says, what is the f value when x is negative 1? So what is the y value when f is negative 1? So we're going to go to negative 1, and we're going to find out where the y value is. So we go down, so it's negative 1, we go down till we hit the line, and that is at negative 2. So our answer for this one is just negative 2. Okay, so negative 1 for x, it hits the line here, which is where y is negative 2. Okay, this one looks funny, but again, it's not difficult. So this says, it has the x in brackets, so it means, what is x if f at x equals 1. So what is x if f at x is 1? And remember, f at x is y. So what is x if y is equal to 1? Okay, so we kind of found that already. Okay, but let's go back to the graph. So it's in what is our x value when y is 1? So y is 1 is here, so we get an answer of positive 2. So we have the answer of positive 2. But y for positive 1 actually has two answers. It touches the graph here at 2, and it goes, if we go this way, it also touches the graph here at negative 2. So we have two answers. We have a positive 2 and we have a negative 2. So you could write this two ways. You could do negative 2 and positive 2, or you could write it as plus or minus 2. That means a positive 2 or a negative 2. Or you can write it this way, it doesn't matter. Okay, so that's how you get them from the graph. So again, when x is 2, what is y? So x is 2, y is 1. We just go up to the graph. Okay, this one, when x is negative 1, what is the value? So we go from negative 1, hit the graph, and we notice that y equals 2, negative 2, sorry. And then this one, again, what is x if y is 1? So again, we go from where y is 1, we could go left and right. It hits the graph at 2 points, so we get a positive 2 and a negative 2. Okay, so let's go back to, or go into the next one. Determine each value if g at x equals 3x minus 8. Okay, so now it says, what is g at negative 9? So let's go rewrite the equation here. Okay, so they're saying originally it's g at x equals 3x minus 8, but now instead of the x, they have the negative 9. So we're going to take this negative 9 and we're going to substitute it into all the x's. Okay, you don't do anything with this side, by the way. Remember, this is the same as y. So this is just y. So they want to know what the y value is when x is negative 9. So we're just going to work with the right side. So 3 times negative 9, negative 27. Subtract another 8, gives me negative 35. Okay, and then that's it. Okay, now b. We have a g at 8 minus a g at negative 3. Okay, so there's actually two parts of the question. So we want to know what is y when x is 8. And we're going to subtract what is y value when x is negative 3. So it comes in two parts. So first we're going to substitute 8 into the equation. So we have 3 times 8, minus 8. So that's going to be the first one. I'm going to put this in brackets since we're going to be doing two different substitutions. So we're going to substitute 8 into the x. So 3 times 8 minus 8. Subtract. Now we're going to do g at negative 3. So we're going to substitute negative 3 into x. So we end up getting 3 minus 3 minus 8. Okay, so now we're going to solve the first one, and then we're going to subtract the answer of the second one. So 3 times 8 is 24, minus 8 is 16. Then we have 3 times negative 3, which is negative 9, minus 8 is negative 17. So we have 16 minus a negative 17. Okay, so going back to grade 8 and 9, when we have a double negative or double subtraction, that makes a positive. So we have 16 plus 17 gives us 33. Okay, so those are those ones so far. Oh my goodness, I forgot 2 questions. Oops. Okay, I'm going to go back to those 2 in a second. Okay, so to finish this one off, okay, g at 8 minus 1. Okay, so now this one's a little bit trick. There is no final answer. We could just simplify. So instead of x here, we have an a minus 1. So wherever we have our x, we're going to substitute an a minus 1 here. So we have 3, and now we're plugging in a minus 1 into where the x is. So instead of having 3x now, we have 3 times a minus 1. So now we're going to expand because we want to simplify it or evaluate. So we expand, so the 3 distributes into both the terms in the brackets. So we have 3 times a, which is 3a. 3 times negative 1 is negative 3. And then we subtract 8, which gives you 3a minus 11. So 3a carried down, negative 3 and negative 8 is negative 11. And then that's it. Okay, so my apologies. I'll go back to the domain range here, and if it's a function. Okay, so is it a function? Well, it's a quadratic, so yes, it is a function. Yes, a quadratic function. Okay, and it also passes the vertical line test, so you could draw a vertical line along this graph at any point, and it only touches the graph at one point. Okay, and now the domain and range. Okay, so since we have a graph, we start with XER and YER. Okay, so we have a quadratic, and hopefully from 1.1 you know what the domain would be automatically. So this quadratic, it keeps going up and up and up and up, okay, but it comes this way. Say this comes this way, keeps going. So we will have an answer for all the positive x's. Okay, I know it doesn't go this way, it actually goes this way, but just for the example purposes, the x will hit this graph at every point. And then likewise, if this graph was continuously going up this way, our negative values, all our negative values will hit this graph at some point. Okay, so that means our domain is just XER. Okay, so it's all the negative values and all the positive values. Okay, so our y values now. So we have all the y values up this way. So their y values hit the graph at all these points. Okay, but we don't have anything below the vertex here. So we have a restriction. So our quadratic comes as low as negative 3, okay, but nothing below it. So it's going to be negative 3 and everything greater than that. So we write y is greater than or equal to negative 3. Okay, so it's everything greater than or equal to negative 3. Okay. Okay, so here's the homework here, page 22, 1 to 7, 9b. But for 9b, you're just doing I. Let me just pull this up for a second in the textbook. Okay, so we're doing 1 through 7. They're very easy math for the most part. Okay, then 9b. So 9b, you're just doing 1, 3, and 5. 1, 3, and 5. Okay, so don't do 2, 4, and 6. And then we have number 11. So 11's here. And 17a. So 17a. Okay. All right. See you guys later. Take care. Bye.